Welcome to the video on solving quadratics by taking square roots. So if you watched the previous videos, then you know that there's multiple ways that we can solve quadratics. One of the ways was by graphing. Graphing, you just have to graph it and then look for the x-intercepts basically. So that one should be pretty easy as long as you have graphing tools and things like that. But we're going to start focusing on solving algebraically. Now, algebraically means that you basically don't have a graph in front of you. You got to start using the x's and all that types of stuff. So we did go over already how to solve by factoring. That was the last lesson, so make sure you know how to do that. Today we're going to go over solving by square roots. And just let you know that we are going to be quizzing on this next week. So just make sure you know these 4 ways of solving. And you actually get to pick which way that you want to solve by. So it says basically pick your favorite. Square roots. So the way square roots works is, first off, I just want to make sure that you kind of remember how to solve, because that's an important piece. If I give you these 3 simple ones, if you're asked you to solve these things, you should be able to do these, I would hope. But basically, these are all 1 steps, and what you want to do is basically do the opposite, the inverse operation. So the inverse of adding 7 is subtracting 7, and then those 2 go away, and you get an x. The opposite of multiplying by 5 is dividing by 5. Okay, and the opposite of minus a 9 is adding a 9. All right. So the inverse operations are basically what isolate your variable. Now, that brings us to square roots. So what's the opposite of squaring something? Opposite of squaring something, we actually have a function for this. It's the square root, okay? We did this, I think, in the past with when we were simplifying radicals and things like that. But basically, if you have something squared, that's the opposite of square root, and square root is the opposite of squared. So basically, if you see a squared and you got to get rid of it, you can take a square root of that. And those 2 will end up going away. You get your x. Now, one important thing that you have to do here, though, is if you take a square root of a number, you need to make sure that you realize that you have 2 answers, a positive answer and a negative answer. The reason why is this. So square root of 25, everybody should know that's a 5. 5 times 5 is 25. But the thing is 5 times 5 is 25, but you also have negative 5, because negative 5 times negative 5 is also a positive 25. So when you take a square root, make sure that you account for the positive answer and the negative answer, and basically split them apart, and you'll have 2 answers. Sometimes, not all the times. And we'll go over more what I mean by that, but most of the time you're going to have, well, not even most of the time, but we'll go into that, like I said. When should I use this method? So first off, I told you that you're going to have multiple ways of doing this. So it makes sense that you know when you're supposed to use a square root one, because you're going to have 4 other choices. Now, you can technically always use square roots. There's just like a lot more work you would have to do if you don't use it at the right time, though. So for example, I have x squared equals 25. Obviously, we just did that one. That one you're going to use it on. Now, I do want you to notice that we've worked with quadratics in the past. We have an x squared part, and we have an x part, and normally we have a number part. But basically, what you want to look for is x squared. If your x is being squared and there's no other x's after you're done simplifying this thing, if there's no other x's and you only have your x squared, you should use a square root, because basically you just square root it and then you get your x by itself. Now this one, you have an x squared, but you also have a 6x. This is not a very good candidate for square roots. Okay, this x part messes it up. Okay, this is called a linear term, but your linear term, basically you don't want a linear term if you want to use your square roots. All right. So if you take a look at this next one, what do you think? Should you use it or not? And feel free to pause the video on each one of the ones I'm going to pop up here and just figure out if you can know when to use it or not. So this one, it's a good candidate to use it because, like I said, you're looking for this x term. Okay, I don't have an x, I just have x squared. I can add 8 to both sides and then that'll be good to go. So that one's fine. This one, you can also use it on that one. There's no x term there. There's an x squared only. This one has an x term, so I do not want to use it on that one. I have other methods that will work better. This one, I don't see an x term here, but it is over here. Okay, so it doesn't matter what side of the equal sign it's on. If you have just an x term, and there's no way for you to really cancel it. Like if I had a positive 7x and positive 7x, I could cancel it off. But here, it's kind of stuck, so I can't do anything with that. So don't use it there. This one's a little bit interesting. It looks like I have an x term, right? But keep in mind, this entire thing is being squared. So this is technically an x squared, um, or even a whole expression squared. So I can take a square root of this and it'll work out nice and neatly. All right. This one, on the other hand, my x is being squared here, but I have a linear term outside of the squared. So that's not a good thing. So again, I should not use that one. Now take a look at these lists that we just made. Kind of figure out a pattern, because you're going to have to look at these problems pretty fast and know, oh, should I just take a square root, or is there other methods like the quadratic formula I should use? So if I look at this don't use it side, I can find an x in all of these. Not an x squared, but just a regular old x. That's why I don't use it there. Over here, they all have x squared, except for this one, but remember, that's in parentheses squared, so I can actually use it here, okay, as opposed to this one where this 4x wasn't being squared, so that's still a linear term, all right? Okay, so that's when we're supposed to use it. So let's go ahead and go over how to use it. So a couple steps here. This is where you want to start taking some notes or pictures or screenshots, whatever you want to do. So first, you want to isolate. We just said we can only use it. We should only use it when something's being squared, and that's it. So you want to isolate whatever's being squared. Get it by itself. Because once you have whatever's being squared by itself, that's when you take the square root. But whatever you do to one side, make sure you do to the other side, okay? And then that little plus minus thing that I mentioned. And then after you take the square root of both sides, that's when you split it into two equations and then simplify the square root, all right? So let's go ahead and see some examples here. I think I got about 3 or 4 examples lined up here. Feel free to have your worksheet out and working along with this. That's probably one of the best ways to do this, is just see if it works out like that. So this one does not have a linear term. I have an x squared, so this is a good candidate for square roots. So first step, isolate what's being squared. So here's x squared. When I say isolate, remember that means that you get it by itself on the side of the equation it's on. Here's your equal sign. I want x squared by itself over here. So I see a plus 4. So I should subtract 4. Those go away. I get x squared equals 16. Okay, good. I got my first step done. My x squared is now isolated. It's by itself. Now that I have it by itself, I'm going to square root both sides. All right, so there's your square root. Reason why I square root is because, remember, square roots and squares, those end up crossing off. And I get just an x. And then I got to stick a plus minus on this thing. Once I have my plus minus, so that's my second step is done. I took a square root. Now I'm going to split it up into 2 separate equations. Okay. One is my positive square root of 16. The other one is my negative square root of 16. And from there, I need to simplify my square roots. If it's a perfect square like this, meaning 4 times 4 is 16, so that's easy to do, then just put 4, okay? If it's one of those ones that are not perfect squares, you're going to have to simplify it, and I have an example that looks like that too. So, and then that's it, okay? You can always take your numbers, plug them back in, see if they work. Negative 4 squared is 16, positive 16 plus 4 is 20. 4 plugged in, 4 squared is also a 16, plus 4 is still a 20, so that's why both of those work, right? Let's go over another example. So second example, x squared minus 8 equals 20. This time, I think the last one was a plus, I just changed it to a minus. So again, isolate your x squared. And feel free to work along with these, or like I said, find the ones in your homework that look like this one and practice with them. So I'm going to add 8, you get a 28. So you get x squared equals 28. That step 1 is done. So I'm going to move on to step 2, square root both sides. Make sure you put your plus or minus on that side, the right side. This left side you don't really need to, because the squares are going to end up canceling off anyways. Plus, if you put a plus minus, it's kind of redundant, because there'll be positive and negative combinations either way. So I got my plus minus on the right side. My x is by itself over here. I'm going to go ahead and split and simplify this square root. So I got a positive square root of 28, a negative square root of 28. Now this is not a perfect square. So like I said, a little bit of a review of what we did in the past. If I have a square root of 28, you can either find perfect squares within that, or you can break it up into its prime factors. I think in our class, most people are doing the prime factoring thing, so that's fine. Since square roots are asking what times what, we're looking for pairs here. So I got a pair of 2's. So the 2 is going to come out front and 7 is going to stay in the root. So square root of 28 is the same thing as 2 square root of 7, 2 root 7. So positive 2 root 7 and a negative 2 root 7. All right, and that one is done. So the next one, so this is example number 3. 3x squared plus 5 equals 32. So a little bit different. If I take a look at the left side, my x squared has a 3 and a 5 next to it. I just want x squared. I don't even want this 3 out front. So I got to get rid of the 3 and the 5. So kind of imagine like this squared wasn't even here. What would you get rid of if it just said 3x plus 5? Would you get rid of the plus 5 or the 3 first? Hopefully you said plus 5. So you're going to go ahead and subtract 5. You get 3x squared equals 27. Now I got to get rid of 3. This is 3 times x squared. Opposite of multiplying is dividing. So divide both sides by 3. I get x squared equals 9. X squared is now by itself. Step 1 is done. Step 2, once your square root's by itself, square root both sides. All right, make sure you put your plus minus on there. Go ahead and split it up. I'm going to split and simplify this at the same time, though, since square root of 9 is a perfect square. Square root of 9 is 3. So I'm going to get a positive 3 and a negative 3. So square root of 9 is a 3. I know I got to split them anyways, so I just go ahead and put a positive 3 and negative 3. And that's it. All right, I think this is the last one. Yeah, so this one. So this is one of the ones that I said look kind of weird when we're trying to figure out when to use square roots. And again, you don't have to. I'm going to show you other methods, but this is square roots pretty easy to use on this one. It says isolate what's being squared. So what is being squared here? This entire group is being squared. That's what you got. That's why you got parentheses. There's nothing outside of the parentheses, so it's already isolated. So this thing is being squared. I have nothing being added or subtracted, nothing being multiplied on the front. So I can go ahead and skip to step 2 and square root both sides. Now, if this said x minus 8 squared plus 7 on the outside, you'd have to subtract 7 first, okay? So square root both sides. It's a big, nice, long square root. Squares and square roots cancel off, so you just get x minus 8 left over. You don't have to write parentheses since there's nothing on the outside to account for those. And then put your plus minus, separate it into 2. So x minus 8 equals a positive square root of 100, and x minus 8 equals a negative square root of 100. So go ahead and simplify this square root. You get a 10. 10 times 10 is 100. And then just add 8. You get 18. Same thing over here. But this is a negative. So square root of 100 is 10, but it's going to be a negative 10. You're going to add 8 to negative 10. You get a negative 2. All right. And with those examples, you should be able to handle the worksheet that I just handed out. So feel free to stop by during office hours or ask me questions on School Loop or anything like that, okay? I hope everybody's doing well. Take care. Bye-bye.